Hey, Algebra 2. Today we're going to work on some application problems. So when we have an exponential problem, sometimes it is exponential growth. In that case, the curve would look something like this. So we have maybe the population is an example of something that grows exponentially over time. This is what exponential decay would look like. So if you think of, unfortunately, some animal populations that are dying off and becoming endangered species. So we always read a graph from left to right. So on this decay, then we used to have a population that was really big, and then as time passes, we move to the right, and the population is getting smaller and smaller and smaller. So we have this formula here for exponential growth. And let's tell you what these variables are. So A of t is the total. That's kind of like y, except that we're writing it in function notation. Your lowercase a right here is your initial amount. We have plus or minus r. So when we use the plus, we are going to have growth. And then when we use the minus, we are going to have decay. It's plus or minus r. So the r is the rate at which something is changing, and you need to make sure that you write it as a decimal. So if your account is growing at 10% a year, you would have 1 plus 0.1, and this would be 1.1. If something is declining at a rate of 10% per year, you would have 1 minus 0.1, and so that means that number right there would be 0.9. And then finally, the t is your time, and it is always in years. All right, so going back to growth. So I was describing if it is growing at 10% a year, that means 1 plus 0.1 is 1.1. So your 1 plus r number is going to be greater than 1. If you have decay, so when I said that something was declining by 10%, we did 1 minus 0.1, which is 0.9. So 0.9 is less than 1, but it's also not a negative number, and it's bigger than 0. So we're going to write it like this. So your 1 minus r number, it looks like this. So you're going to get a number that is sandwiched somewhere between 0 and 1. We use this for a lot of application problems, but sometimes it also looks like this. Y times a times b to the x. So this a, they're in the same location, and so if it's in this format, a is your initial amount, and then b is still the rate at which something is happening. So you might see it one of two ways. All right, so we have to decide when we look at a function, is it growth or decay? So your growth and decay had everything to do with whether it was 1 plus or minus r. So it is the part that is raised to the exponent. So when I look at number 1, 12 times 0.95 to the x, so the 0.95 is the part that I'm focusing on. 0.95 is a number between 0 and 1, and so this is an example of a decay function because 0.95 is less than 1. On number 2, I know that it is the 2. It's the number that's being raised to the exponent. So this is an example of growth because 2 is bigger than 1. And now on number 3, I'm looking at the 4/3. So you can't just say all fractions or all decimals are decay, because 4/3 is certainly bigger than 1. So therefore, this is a growth function because 4/3 is greater than 1. All right, so we have an application problem here. Ashley's going to take a job. She has a starting salary of $40,000. She gets a 6% raise each year. How much will she make after 7 years? All right, so we want to find out the total. So we have A of t. This is the total that she's going to make. That's what we're trying to find out. Let's see, here's the formula. A of t equals A times 1 plus or minus r to the t. Your A is your initial amount. So right here it says I have a starting salary of $40,000. So therefore that's your A, 40,000. She gets a 6% raise. So when you get a raise, that means it's growth. It is definitely going up. So that is a word that means I need to use the plus sign. So your raise is 6. And we're going to turn this into a decimal, move it 2 to the left. We get 0.06. And t is your time in years. We want to know how much will she make after 7 years. All right, so in function notation, A of t, so you should put your 7 right there. Your initial amount is 40,000. We have growth, so we're definitely using the plus, so I have 1 plus 0.06 to the 7. 1.06 is just 1.06. 40,000 times 1.06 to the 7th. All right, so you should be able to enter this directly into your calculator and get an answer. And she should be making $60,145.21. Here's one that we pulled off of an SAT review question. So here is multiple choice. There are no jackrabbits before 1788 when 24 were introduced. 24 are introduced. So that is going to be your A. So A is your initial amount, and that is going to be 24. It had reached 10 million. If it had grown exponentially, this rate would be a 16.2% increase. So your rate is 16.2%, and that would be 0.162 as a decimal. Which of the following best models the population? Okay, so we have it. Instead of A of t, it wants me to use P of t. So P of t equals A times, I'm going to go 1 plus r to the t. So we knew that it was increasing, so we are definitely using the plus sign here. P of t, so we don't know the total. We do know the initial amount, so I'm going to plug 24 in there. 1 plus 1.162 is 1.162. And it just is saying after t years. So it doesn't give us a specific point in time. And so this is what the function would look like in generic form, not knowing how many years we're talking about yet. Okay, so A, nope. B, nope. C, yes. Here, I don't know what all these little parentheses and dots are for. That's bizarre. So that's the part that doesn't make sense to me on D. So that's why we chose C for the good answer. So we did, pardon me, 2 that can increase. Let's do 1 that will decrease in value. A new car sells for $18,000. It depreciates 25% each year. Write a function that models the value of the car. Find the value after 4 years. It sells for $28,000. So that is your A. Your initial value is 18,000. Depreciates is a word that means to go down. So cars depreciate in value, computers depreciate in value. Generally, if you run a business, any kind of equipment will depreciate in value. So it depreciates 25% each year. So think about, for your R, write it as negative. So if you see depreciate go down, go negative 25%. So this should help you remember that you're going to use the subtraction sign. So I'm going to move it 2 to the left, so I get negative 0.25. And then your t is going to be 4. So my general function is a of t equals a 1 plus or minus r to the t. So your initial value is 18,000. 1 minus 0.25 to the t. It's initially talks about writing a function. So that's why I'm not putting in the 4 yet, because I'm showing you what function looks like versus solving it to find the actual value. 1 minus a quarter is 0.75 to the t. All right, so this right here, this is what your function looks like. Now let's go ahead and plug 4 in for your t. So you could run this string in your calculator, and the value after 4 years is $5,695.31. That is my current value. Number 7, a certain animal species decreases, so I'm definitely going to use the minus, at a rate of 3.5% per year. So there's your R. You have counted 80 animals in the habitat you are studying. So there's my initial amount. Write the function that models this. All right, so my R, it's decreasing, is negative 3.5%. Let's move that 2 to the left, and we get negative 0.035. Your A is going to be 80, and eventually, we don't know t yet. Okay. A of t equals, all right, so I'm going to conserve room. I already have my formula right here, so this is what I'm going off of. I know that my A is 80. I know that my rate is 1 minus 0.035 because it's decreasing to the t. A of t equals 80. 1 minus 0.035 I found was 0.965 to the t. So this right here is my function. Now, once you have your general function, now it wants me to estimate the population in 5 years. So now you just need to plug 5 in for your t. A of 5 equals 80 times 0.965 to the 5th. And when I multiplied all that out, I got 66.94. And animals, we generally round to the nearest whole number, and we would say that there's probably about 67 animals in the habitat. There we go. All right, number 8 and 9 are very different than what we've been doing. Ashley has an initial salary of $40,000. So A is your initial value of something. She now makes $60,000. Your A of T is your total, and so, or your future amount. So that is the value that goes right there. I get a 6% raise, so R equals 6%, so it's 0.06. How long has she worked at the job? So that is my mystery amount right there. A of t equals A times 1 plus R to the t. I went ahead and used the plus because I saw that she was getting a raise, and a raise means that I'm going to use the plus. I also know my future value, so that is where I'm going to plug the 60,000 in. Your initial is 40,000. 1 plus R is 1 plus 0.06 to the t. That's what I don't know. All right, 1 plus 0.06 is just 1.06. So here, I need to solve for t. So I have to use what I know from exponentials to solve this. So the first thing that I'm going to do is I'm going to get rid of this coefficient. I'm going to divide both sides by 40,000. So 60,000 divided by 40,000, I got 1.5 equals 1.06 to the t. All right, so you've done lots of problems like this before. I have these two bases. I have to solve for my exponent. I know that I have no chance of getting the same base with 1.5 and 1.06. So if you have no chance of getting the same base, then I'm going to change form. I typically have my exponent on the left, so I'm going to rewrite this as 1.06 to the t equals 1.5. So when I say change form, I'm saying go from exponential, which is what you're looking at here, and I'm telling you that you need to put this into log form. That's what you're changing. So here's your base. So I have log base 1.06. That 1.5 comes over, and then the exponent goes to the other side. So I'm using all my skills on this problem. I have a number here, and I have a number here. When you have a number and a number, I'm going to use my change of base formula. So I have, how about I include log? So I have log 1.5 divided by log 1.06 equals t. I'm going to go log divided by log, and I got 6.9585, which rounds to about 7 years. Try the next one on your own, and check my notes when you're done. Thanks.